All right, good morning, everyone. I hope you're doing good. I'm actually here to talk about, with my friends, yesterday we actually witnessed the first open source marriage on stage. Today we're going to talk about a different kind of marriage between technologies. I'm Sean Koeng. I'm a product manager in an OpenStack team focused on everything storage. I have with me two of my colleagues.
I'm Federico Lucifredi. I'm a product management director in the Ceph storage team.
I'm Sebastian, principal software engineer, mainly working on Ceph, but always rotating between different technologies like Ceph and OpenStack, Ceph and containers, Ceph and configuration management systems like Ansible.
Awesome. All right, so we're going to take you through a quick journey this morning. We'll start by walking through what OpenStack is all about. Then we'll talk about what Ceph is all about, and then basically the whole integration story. Those of you who doesn't know OpenStack yet, welcome to the 21st century. This is by far the largest open source movement and project on planet Earth today, with more than 500 companies involved, millions of code lines. By far, this is the vastest cloud infrastructure project exists today. And the reason is, and also one of the reasons it's an open source project, because we're solving a huge problem that cannot be solved by one individual, let alone by one company. So let's go ahead and get started. I wanted to start actually with where we are in OpenStack adoption. This slide is actually from the OpenStack Foundation user survey that was done a couple of months ago. Basically showcasing that OpenStack is now maturity, where we see a lot of customers are running it in production. And this is actually a great testimony of where the project is. OpenStack has a 6-month cadence in terms of software releases. And the adoption curve we're seeing of customers are moving into production using OpenStack as their choice of cloud infrastructure, both for private and public clouds, is a great testimony. And this is really live. So this was like 2 months ago. If we'll do the service today, we're already bumped, right? This is a very fast-moving train. Let's talk about how OpenStack actually fits with our overall strategy at Red Hat for open hybrid cloud, right? OpenStack is our cloud infrastructure layer. It's the infrastructure we build roads basically to allow applications to move just like cars on that infrastructure. And customers are actually going through their fourth industrial revolution right now that started all the way from moving to a physical, to virtual, private clouds, public clouds, and there's no single customer that actually took the same path there. We're seeing industry today that use OpenStack, like the telcos, they totally skipped, for example, virtualization era, right? They're totally jumping now and replacing their network equipment, physical hardware with VNF applications running on cloud. So it's a very disruptive time where we actually part of that movement and allowing IT to transition. And the reason I love this slide because it showcases not just how OpenStack fits in, but how OpenStack impacted by the rest of the layers. For example, we're here today to talk about the storage, software-defined storage with OpenStack. And you'll see how the DNA of the principles are very similar, but to solve different problems. We have all the way to the top with our container management, right? Because as I said, we're servicing the cars that run, which is the application workload. So we'll see that we basically have very tight integration with all of the layers as we'll go through the slides. So what's the mission statement of OpenStack in general, right? So our job at Red Hat is actually to take that wild, rapid, fast innovation train called OpenStack and get it to the enterprise level, right? So as I said, we have a 6-month release cadence, and we basically taking that code every 6 months and we make it hardened, secure, and production grade. The benefits, of course, allows you to use it both in your private cloud offerings or private cloud with the highest standards and, of course, the high performance. And a key point is that we base our OpenStack platform on our fundamental Linux platforms, right? So we just changed in our OpenStack Platform 8 release the name from RHEL Enterprise to just OpenStack Platform. And the reason we included that name is just to showcase the tight relationships with the OS. In a sense, OpenStack is one layer of the solution, right? If we need to do work, even just provision of a virtual machine in OpenStack, it actually calls underneath projects like Libvirt to do the work, right? So we have a very tight integration with the KVM stack. We have a very tight integration with the operating stack. And in a sense, to deliver OpenStack is not just delivering OpenStack, because we need to take care of all of these layers, right? And we'll see how deep it goes. When you look at the infrastructure, the goal is basically to provide that elasticity we need and scale capabilities, both in the infrastructure and the application side. So if you look how we actually integrate, and this is going back to my earlier picture showing how it all fits together. So if we're managing a private cloud, we basically have the platform to use all the services I need using OpenStack to deliver the compute, the storage, the networking, and of course all the as-a-service, new service that we need to serve today in a cloud fashion. But what about software-defined networking? What about software-defined storage? How it all is basically aligned together. And here is basically we have a very tight integration in each one of these pillars. The telco NFV that I mentioned earlier, a lot of the innovation we're doing in the telco NFV space is not in OpenStack. It's actually in RHEL. Right? Think about it. All the NUMA pinning, CPU pinning, et cetera, actually take place in a lower end in OpenStack. What about applications? So OpenStack is basically enable us to be much more agile, right? Deliver faster. I was here this week talking to a lot of customers who've between the time to adopted OpenStack and after the time to adopt OpenStack, we're able to streamline the time it takes to them to production, right? Going through weeks on the application production change to 20 minutes. This is what it's all about. Cost is a huge driven. Open is a huge driven because now we have all the choices to plug into OpenStack with the large ecosystem available, but it also streamlines your way to deliver your applications, right? Wherever it's the tight integration we have with the Red Hat Atomic platform for the containers management, as well as all the converged infrastructure and management that we have out of the box with CloudForms to manage it all. When it comes to certification, so as I said, OpenStack is all about being a pluggable infrastructure. It allows you to connect different components, as I mentioned, storage, network, et cetera, into your cloud. But we need to make sure that whatever you plug into it actually works and doesn't jeopardize your production, right? So we actually introduced a certification plan which is specifically to OpenStack that adds as well to the certification we already do at the RHEL operating system level. The benefit is now we have more than almost close to 400 members certified since we initiated in April 2013, and now we're actually close to 1,000 certified solutions already. This brings you the ease of mind to know that whatever you're going to plug into your cloud infrastructure actually works, right? And this is, we have a great partnerships with a lot of the ecosystem players, and it's our goal basically to provide you that choice. OpenStack is all about choice, right? When we look at what's the framework, so yeah, we have all the services, as I mentioned, if you look at the infrastructure as a service layer. So you have the compute with Nova, we have the storage pieces that I'm going to go into in my next slides, networking, bare metal provisioning, right? And I have also the managements, as you can see on the right. What about all the infrastructure as a service plus services, right? Because as I said, we're building roads, right? This is if you will, the first layer is just the road level. What about, I need now to curve databases or a Hadoop flavor and give it to my analytic team, my scientists to run a job in a cloud fashion, right? Before cloud infrastructure was there, I had to take a bunch of hardware, Hadoop software or Splunk, whatever, stand it out in long-term investment, maybe to run a job once every 3 months. In a cloud time, I can actually allow, there's no interaction with the IT. the same data scientists just go, provision, pick up the flavor of a dupe they want to run in OpenStack Sahara, and run the job and basically kill it and reclaim the hardware, right? That's what cloud is all about. This is the agility we're bringing to our internal service users. So we have a lot of monitoring capabilities with ceilometers, data processing with Sahara, orchestration with Heat. And if we look at the bigger picture, every release of OpenStack, we actually introduce new services. I call it OpenStack on steroids. Every release, we have new services joining as under the big tent of OpenStack. Our goal in Red Hat is actually to make them production grade. We invested a lot of time in engineering to be participating as catalysts in OpenStack different projects and new initiatives. Once they mature, we bring it to you as a customers, and we make it part of the offering. So, for example, we have new additions. I mentioned Sahara was added a few releases ago. Manila is about to be added. Manila is all about share files as a service. We're going to talk about in the next slide. And as you can see, we have our Red Hat Enterprise Linux as a base that basically serves as the underlying platforms for our OpenStack offering. Now that we understand what OpenStack is all about, let's talk about storage. Now, as you can imagine, storage as a service, right? And if we drill down to storage as a service with OpenStack, we actually have 4 different projects just to allow us to provision persistent storage to our cloud infrastructure. So the first and most common used is, of course, the block storage, Cinder, that allows us to provision block services to our VMs or containers on the top, and in a pluggable fashion. In a sense, pick your favorite hardware vendor that has a Cinder plugin. You can connect it to your OpenStack infrastructure. It means you can use your legacy, traditional backends, as well as the more software-defined offering that has a Cinder backend. And basically what we're doing in the Cinder community is basically enabling all these capabilities. If it's replication, consistency groups, or any other feature that you can do today, offload to your storage backend, right? Just like in virtualization, you're moving up the chain. So I need basically to offload as many capabilities of data processing and storing and data placement when it comes to how do I utilize the storage backend I have in my different cloud infrastructure. And it can be, of course, different in terms of locality. You can have several sites and, of course, build a whole service catalog when it comes to storage, right? I can have different service catalog with different storage SLA and quality of service for every application workload because they're not the same, right? Each workload has different characteristics when it comes to storage requirements. Some of them needs to be more protected, some of them needs to be more high available. And again, if I'm a customer, going back to my example earlier, I'm an internal user, even at tenant level, I can go and provision my own storage without going to IT. It's all about self-service, right? I need it now, and I'm provisioning it to myself. That is where it's all about. Glance. Glance is our image store. So all of you have been dealing with images of VMs, etc. We need a way to manage them in OpenStack, and this is where Glance is all about. So wherever we're provisioning a new VM, basically Glance is behind the scenes managing the repository of images and templates, the application templates. But what Glance also allows us to do is make sure that these images are handled in a secure way, or sometimes replicated, protected. I can put it in an object storage, for example, which is one of the next other offerings we have in OpenStack. As I said, it's all about choice. Shared files as a system, systems, Manila. Manila basically is a relevant new project that we in Red Hat participated in the upstream community to deliver to our customers. Yesterday, I think Amazon just made their EFS production. Great EFS is Elastic File Sharing Service, very similar to what we have with OpenStack. But as you can imagine, AWS supports NFS only, right? Just like Azure File supports CIFS only. What about OpenStack? When it comes to Manila, you have all the choices in the world because as a user, I can now provision my HDFS, CephFS, or any CIFS, NFS out of the box. And guess what? It has a backend. You can actually use different backends or software-defined storage, right? It's all about choice. Last is Swift, that comes out of the box. It's basically our storage offering, object offering that can be, we see a lot of the uses of Swift for small files management, et cetera. Dropbox use case, if you will, as well as backup, right? Like a backend for glance for images. So as you can see, we have like 4 different services just to manage storage in OpenStack. And this raises actually, what about how do I manage it all? So to talk about some of the challenges and solutions, I'm going to hand it over to Federico. That's going to talk about why traditional storage solution basically doesn't work in this model.
Thank you, Sean. So as you switch from traditional virtualization to a cloud model, the storage solution has to move the same way. So the problem is in multiple aspects. First is integration. As Sean was saying, there are multiple interfaces. Are you really going to have multiple storage silos providing these interfaces to the cluster? Are you going to run multiple capacity planning exercises for these silos? Are you going to have multiple people or even multiple teams maintaining them? It is just not realistic, and it's also crippling the economics of the fact that you just got last generation compute, but you're stuck in the last century with storage. Capacity planning has other aspects. If capacity planning comes from multiple pools, you have headroom in multiple storage pools, meaning you have multiple budgets for extra capacity. While if you are using a single cluster, that same headroom can be consumed as glance images, Cinder volumes, Swift object. It doesn't matter. So it simplifies the cost massively, not just in terms of the people problem, but also in terms of the storage problem. Additionally, you have the agility issue. As you want to scale your compute quickly with going to the Dell website and adding 30 nodes to your compute cluster, with a software-defined storage solution, you can do the same on the storage side. If you are bound to a traditional storage vendor, you cannot do that. Never mind the cost aspect. So that's in a nutshell where the problems are. So we at Red Hat believe that the future is in software-defined storage, that we are moving from traditional appliance-based storage based on proprietary hardware and closed source software designed literally in another century to a new model that is based on clusters of commodity x86 servers that have to meet certain power specifications for certain performance ratings, but have nothing special. There is nothing special about them. And you're just running software to build a distributed storage cluster on top of that. Now, of course, we are Red Hat, so we believe that this should be open source. I think that will not come as a surprise. We don't strictly believe that the traditional storage model is bankrupt. We believe that there is a place for it. But we believe that the traditional storage model will bankrupt you if you use it in the new cloud world. It will not come to a surprise to anybody that there is an explosion of storage going on. The economics of traditional appliance-based storage are not suitable for the amount of storage that customers are telling us they need to use in the next 5 years. In the last 2 months ago, I was in New York City meeting with a senior member of the technical staff of one of the world's 10 largest banks. This gentleman told me, here, storage is a $700 million problem when we project the current architecture to 2020. Now, if you think that $750 million is a reasonable storage budget for your organization, then you do not have a problem. Otherwise, you need to look at options to move into the current world. So what is Ceph? I cannot begin to describe Ceph in one slide, but Ceph is an open source, software-defined storage system that has the most momentum out there by far as a software-defined storage platform, and is the dominant platform in OpenStack. Since the OpenStack Foundation has been tracking metrics for component use, Ceph has been consistently at the top. Not by a little bit either, we're over 50% of usage. This is because of the technical aspect that we were discussing before. It just makes sense to have a single storage system providing storage to the 20-odd services that you may be running in your OpenStack cloud. This also comes from the fact that the original sponsors of the Ceph project, the Ink Tank team, moved early to integrate with OpenStack and gained that position as a result of that. The aspect of Ceph that I would like to highlight, since we cannot really describe how it all works in 2 minutes, is the community aspect. Ceph is not a one-vendor solution. It is not a one-vendor open source project. We have all the major and some of the non-major Linux vendors supporting Ceph. We have all the major OpenStack vendors either supporting Ceph directly or as part of their OpenStack solution. We have major hardware vendors, Intel, Supermicro, Dell, SanDisk, committed to the ecosystem, and it goes on and on and on. This makes Ceph significant in the sense that, think about it when you're cutting the next check to your storage vendor. How many alternatives do you have to get that storage system? With Ceph, if somehow your vendor drops the ball, you have options, and you don't need to redesign and re-architect your solution. You're going to be using exactly the same code. This is how Ceph looks architecturally. Ceph, at its core, is an object store. RAIDOS, Reliable Autonomous Distributed Object Store, is the object store that Ceph uses to store data. It is a distributed object store that attempts at being autonomous, the word being that it tries to take care of moving data, recovering from errors, and all the actions that would require human intervention for ongoing preservation of your data are taken automatically, so that you can just assume that the storage cluster is going to maintain the data at the resiliency level that you specified. That is the design aim. The other design aim is that Ceph was designed to be indefinitely scalable. There may be implementation constraints to build in an exabyte cluster today, maybe, but there are no architectural constraints. A Ceph cluster can continue to grow on and on and on, and if there are implementation to details today that would get in the way, they can be changed without changing the architecture. Today we're comfortable in the, I would say, 10 petabyte range. We feel that Ceph is just fine out of the box. There are important sites like the European Research Center, CERN, in Switzerland, that has run tests with 30 petabytes of Ceph. They tuned a few things, and it worked fine. Yahoo also is a known major user. They use it to back Flickr and other properties of theirs. They run what they call a supercluster, or cluster of clusters that's approaching 100 petabytes in size. So this is really resembling Linux, the Linux movement for storage. It's a vibrant ecosystem, a vibrant developer community that is composed by partners and competitors, but we're all working together to build what we see as the future of storage. Over RAIDOS, we have interfaces that provide standard storage attached to the cluster. So the most obvious one is RGW, which is a translation layer that translates the native RAIDOS object protocol into the semantics of Amazon AWS S3. There were sessions yesterday on using Ceph as an object store. Well, here we're focusing on OpenStack. Our other major use case is using Ceph to provide Amazon AWS S3 compatible storage in a private cloud environment. RBD provides a block storage interface to Ceph that is consumed then by OpenStack to provide the storage services that Sean was describing earlier. And in tech preview right now, but stable and ready for testing, we have CephFS, which provides a POSIX interface to the store and the illusion of a file system. And if you are into technology rather than cost cutting, the architecture of CephFS is quite fascinating. But we cannot go into that here. We are just picking one technical detail to give you a taste of the technology so that you are interested in looking at it further. So usually when we have discussions as to how Ceph works with new people, we get this glazed over look as to how is this possible. And usually the how is this possible feeling all comes from here. Crush is a distributed hash table. How many in the audience know what a distributed hash table is? I know that there is one person in the front row who does. All right, we have a couple. Distributed hash tables are algorithms that provide placement solutions for the problem of peer-to-peer networks, usually. They are how a peer-to-peer network knows where the data is on another node in the same network without a central server providing the answer of it is over there. And that is why Ceph is indefinitely scalable, because there are no bottleneck servers that you need for metadata or for lookup. But there is just this distributed hash table algorithm that allows a client to determine where the data is and go fetch that data directly, that we have this theoretically infinitely scalable design. Now, Crush lays on top of distributed hash tables a few more properties, the most interesting of which operationally is the fact that you can define constraints on placement rules, so that practically you can do things like saying, well, I have these 3 racks of storage, and I would like the 3 replicas of my data to be located in 3 different racks. So if I lose an entire rack of storage, I still know that I have 2 copies of the data. I'm still fully resilient. So Crush has a constraint language that allows you to specify these constraints. Sage gave a master class in Crush yesterday, and you can look up the slides and possibly the recording of the talk in the Summit archive. So in terms of what have we been changing, we have been working very hard on the Ceph 2.0 release, which is based on what upstream is called Jewel. And here are the new features. I'm not going to go into all of them, but the themes tend to be enterprise-focused, like support for the latest authentication protocols, enhancements to our Swift or S3 compatibility, tech previews of what is coming. CephFS I already discussed. We also have a new backend that significantly enhances performance. We have had better than 300% speed up with every single benchmark we threw at this new backend. And we expect that when we go to production, that is going to hold. But it is in tech preview right now, so that you can have a view of what the future looks like in Ceph performance. Today, we feel that performance is perfectly adequate for the OpenStack block workload and for the Amazon AWS S3 store. But as I described before, our vision is that we're the Linux of storage. We want to cover a whole lot more workloads, and so that is a stepping stone in that direction. For OpenStack specifically, volume mirroring is the most interesting feature. This is block volume mirroring. The same speakers you have here today gave a talk at the OpenStack Summit a few months ago describing replication for disaster recovery in detail. that is what this enables. You could have multiple OpenStack clusters, replication of your volumes, so that if the primary site disappears, the secondary site is immediately ready to pick up with the same volume images in a point-in-time consistent state that can be booted immediately. There is a correspondent version of this for the object use case, which is multisite v2. That is also disaster recovery replication, but it is more. It is replication of the same data across multiple object clusters. So it has also a different data propagation application. I'm going to call out one more thing, which is that we have an interesting position in terms of more than half of our users being OpenStack users. So distributed systems, traditionally hard. We get Linux system administrators that come from the OpenStack world and they just go, Ceph is easy. But we're also attacking the traditional storage world, and we want to appeal to the experience of appliance administrators that expect an opinionated experience, so to speak, where the tool knows what the best settings are and they don't have a desire to run with root, so to speak, on their storage. They just want the console to take the decisions for them. And that is why now we'll have two install paths. The expert experience is the one that's backed by Ceph Ansible. I believe we're the first Red Hat product to switch their default install to Ansible, and we're quite happy with it. We can just have the customer define rules in the playbook that we provide and build a cluster straight from Ansible. That is a DevOps approach. It requires a Linux system administrator. Conversely, on the Apple experience kind of the world, there is a new storage console that we are introducing with Red Hat Ceph 2.0. And in this scenario, you have a click experience with a GUI that provides all the default settings, and you just go through a wizard saying, I want to build a cluster with this many nodes. You're prompted with a few questions, and we use our expertise to take the rest of the decisions without exposing you to 100 tunables. And from there, we're going to look at the integration.
Thanks. Sorry, thanks, Federico. So now that you guys know about OpenStack and Ceph, we're going to really start being a little bit more technical and dive into the state of the integration of Ceph into OpenStack. As discussed previously, every 6 months, the OpenStack Foundation is doing a survey, and it's just about just filling the community, gathering use cases, and basically just seeing the adoption of Ceph. And as we can see here in that picture, the first one, Ceph is really dominating the adoption. So for the vast majority of the OpenStack deployment, Ceph is the de facto storage solution that is being used to back all the OpenStack components. On the second one, it's a sort of a zoom in into one of the OpenStack component, Cinder. Cinder is the storage solution to provide persistent storage to virtual machines, where you can basically attach plug devices to your virtual machines. And as we can see here, Ceph is up to 45% in terms of adoption. I believe that, but Sean might correct me, Cinder has more than 70 drivers. So it's kind of a good achievement for us that it's really being used, almost like 50%. And it's growing every single survey. But why is that? As we also explained earlier, it has been a real effort, a real ongoing effort since the very beginning, and since even before OpenStack was a thing. We always made sure that every single time we had a new version of Ceph, a new functionality, same goes for OpenStack, that we tightly integrated both, make sure that they all work well together. So that's why for us, the Ceph is really the foundation of our storage stack. When we are deploying OpenStack clouds, it's really the de facto storage solution that we are using to deploy Ceph. As Federico explained, it's really flexible, and it's a really unified layer because it has several interfaces, and it kind of solves all of the challenges, all of the storage challenges that we have as part of OpenStack, because we have so many storage interfaces to deal with. And Ceph, from the get-go, was really built and designed for cloud environments. So it's really built to work at scale for large cloud environments. Obviously, it integrates really perfectly with all of the OpenStack components, things that we are going to describe just now. So if we start from the bottom, there is the Rados cluster, so the main entity of Ceph, things that we just described a little bit. So it's the general entity that is responsible for managing your cluster, doing health check, self-healing, self-managing, all of the things that you're kind of expecting from a storage solution. But all of this is being done by a software because it's all is software managed. Now, if we dive into some of the components of Ceph, you will see that we have months. So for monitors, they always come by odd numbers. So in this case, we have 3, but we can have 5, 7. But for the vast majority of the OpenStack deployments, we go by 3. We kind of recommend that once you go beyond the petabyte, then it's good to have 5, but just everything below this value, 3 is perfectly fine. So these are responsible for managing the entire cluster, like maintaining cluster maps, doing memberships, and they all work with the Paxos algorithm. We have OSDs, object storage daemons, responsible for serving, retrieving, storing, replicating, backfilling, scrubbing data, all of the things that you're really expecting from a storage solution, basically. So basically, storage daemons. We have MDSs. In this picture, we only have one, but we can have as many as we want. MDSs is the metadata server, which is responsible for providing the CephFS, so the distributed file system of Ceph. And then the latest component, the one that we briefly touched on with Federico, is the Rados gateway, which is the object REST interface that allows you to store your data as objects. So it's really the equivalent of Amazon S3 or OpenStack Swift. And in this case, it really acts as a replacement for OpenStack Swift. So you can, because we have the ability to connect to Keystone, which is the identity service from OpenStack, managing users' credentials, giving authentications, providing access to services and to users. So Rados Gateway has the ability to connect to whatever version of Keystone you're using from V2 to V3. We recently brought the support for V3 with Rados Storage 2.0. As you can see, the Rados Gateway is connected to, is using a library called librados. Librados is just a simple library, it's a simple interface to interact with your storage cluster. So this is how we are just basically interacting with the Ceph cluster. Then if you go from Cinder to Glance to Nova, so Cinder, block storage service from OpenStack, Glance, image catalog, and Nova, resource, so basically providing resources for your cloud virtual machines, we will see that they all use the librd. So once again, the library to access Rados block devices. As we mentioned, everything in Ceph is an object because at its core, Ceph is an object storage. So librd with RBD block devices is just a way to expose Rados objects using a block device interface. What is really good is that those 3 are using the exact same interface, and Ceph has really unique and nice capabilities such as snapshots, clones, copy and write cloning. So basically, when one interacts with the other one, we are getting a huge benefit of those functionalities. So for example, when you're booting an image that is already present in Ceph, we do a copy and write clone, and this image ends up being a clone. So when you try to boot a virtual machine, it becomes really fast. Same goes for snapshots. When you want to do a snapshot of your OpenStack VM, and you do a snapshot at a Ceph level, that makes the entire process really fast and really snappy. So this is part of the unified story once again, but it's really nice to have. Manila, the distributed file system as a service for OpenStack, has the ability to give access to your guest instances to multiple file systems. Once again, this is being done by yet another library, the libCephFS, which interacts with the Ceph file system. And the last component is Ceilometer. Ceilometer is the telemetry service from OpenStack, responsible for gathering metrics from the OpenStack environment. All of these metrics are stored as time series in OpenStack, and time series then are stored as objects in Ceph. One thing to mention is that as part of from a product perspective at Red Hat, we are not supporting yet the Cinder integration, but work is on its way, and it's currently being QA'd, so it will soon be available and supported with the new backend. Obviously, we have a really tight integration with our product. If you go with the Red Hat OpenStack Platform 8, now what you get is a 64 raw terabytes included as part of the bundle, which is really nice because even if you have already an engagement with any software vendor or any storage vendor, nothing really prevents you to have a Ceph cluster, this tiny one, along with your main storage solution, so you can start doing a POC on Ceph or just playing with Ceph, see how it's integrated, how it's reacting, how it performs within your OpenStack environment. Obviously, it's part of the deployment tool that we are using at Red Hat, the director, the OpenStack Platform Director, and it's definitely the default solution that we are implementing for every single cloud that we are deploying. So Ceph is really part of the reference architecture at Red Hat. So now we're going to dive a little bit more into architectural examples and how Ceph can really be deployed along with OpenStack. So the first case here is the hyperconvergence. Hyperconvergence is a really buzzy, fancy word, but it's nothing really complex. It's just something to briefly explain. It's that you have the ability to simply collocate compute and storage resources on the same box. And this is really nice because it really reduces the hardware footprint, and by that, it definitely increases the hardware utilization of your machines. But this all comes at a cost, is that you must have the ability to really finely control the resource consumption of the storage and the compute. If you don't do this, you might end up in really bad situations like CPU memory starvation, where when one machine or one storage daemon is really accessing and consuming a lot of resources from the machine, so then everything can start collapsing. Fortunately, we have all of the bits ready, first from the Linux kernel with control groups, the C groups, so we can basically have a specific context for specific processes to make sure that they are all restrained. We have NUMA awareness and CPU pinning as part of OpenStack, so we can really easily say, I have one socket, 12 cores, and I'm going to dedicate 6 cores for OpenStack, for Nova, and 6 cores for Ceph, for example. It's really easy to do. We also have the ability to restrain memory access from the KVM hypervisor, so we can simply specify this amount of memory will be dedicated, and I won't go over that value as the KVM hypervisor. It's obviously something that is part of the containerization vision of Red Hat as well, because hyperconverged infrastructure are playing quite well with containerized environments. So for us, it's also because containers are really bringing a lot of nice benefits. Things that I explained earlier with control groups, for example, are something that are really embedded into the Docker engine, which is because in our case, we're using Docker as a container engine. All of those C groups functionalities are part of the package. So when you're running a new container, you already have the right C group context for this container, and by that, you're already sure that it won't take more resources than it's supposed to do. And from an operational perspective, it's something that is really nice as well, because operators, they don't always need to have something being configured. So they first do a pass with the configuration management system, and then they run the container, and then configure C groups. So it's something that is really nice and really well packaged, and then really easy to do. We really get this nice and good isolation that the containers are giving to us. Moving on to containers too, we are obviously benefiting from the really good goodness, all of the goodness of containers, from installation to upgrades. It makes the entire process really easy. Something a little bit more technical, but from a pure performance perspective, it might be really interesting as well to run an hyperconverged infrastructure, because as soon as you have virtual machine resources plus storage resources collocated on the same machine, you have, well, chances are that you can get, if you have one VM issuing an I/O, even if Ceph has a pseudo-random distribution, chances are that you can get a local hit, so the I/O can go first on the local disk, and then the replication will go on. But basically what you're saving is one hop from the network, which is something really valuable because, yeah, just really valuable. So this is a hyperconverged node in depth, and you will see that everything is really simple. At the very bottom, we have the Linux kernel, which basically represents your Red Hat Enterprise Linux. And we have our KVM module to have the, well, basically the virtualization engine, and then we have the Docker engine for containers. All of the boxes that you see here are effectively containers. So even for virtual machines, we are running the QEMU KVM process within a container. It's a privileged container because this process requires access to dev KVM, but these are all containers. The same goes for object storage daemons for Ceph. They all run on containers. So the PID one of the container is the Ceph OSD process, and this process is just accessing one disk on the machine. Same goes for all of the OpenStack components from the network with Open vSwitch to Neutron, and same goes for compute resources, libvirt to Nova Compute. So this is basically how that's going to be deployed. The second use case that I'm going to explain to you now is the multisite one. Going back to what Federico mentioned with the new feature from the Ceph 2.0, we can now do proper multisite and disaster recovery. So what we do here is that we are basically reusing the stack that I just showed earlier, the one with the tight integration of Ceph into OpenStack, and we are simply duplicating this functionality across several locations. So what we end up with is multiple isolated OpenStack environments, which for us are easy to deploy, easy to maintain, well understood, and well deployed. So we stick with a single location. We don't do anything like stretched OpenStack environments nor stretched clusters. Stretched clusters are rarely supported, to not say they are not supported by default. And what we are basically relying on here is the new feature, the RBD mirroring one, which just allows you to replicate block devices from one location to another one. And this was what, just to give you a little bit more background, if we had to end up deploying this new functionality in Ceph, it's just because Ceph by design is synchronous. So if you try to do a stretched cluster, then you will have to wait for you have several locations, you issue an I/O, and then you have to wait for all of the clients to send the acknowledgement, which can be really slow and definitely not recommended. So we have to build this new functionality to basically mirror block devices from one location to another one. It's kind of a close and really cross replication. So we have side A and side B, and they both have live images and that are being copied. So this is the, really in-depth, but that's not that complex, you'll see. If we go from the top, it's called, can't really see it, but it's a shared keystone with regions. So what we have here is we have two sites, actually two regions. As we discussed, isolated OpenStack environment. The only single thing that is being stretched out here is the Keystone database. It's the Keystone daemon. Because Keystone is just responsible for maintaining users, groups, services, tenants, roles, catalog, and things like this. So it's really nice from an operational perspective to have this single, unified, and global namespace for your authentication. So what we are sharing here is the Keystone database plus the Horizon dashboard. And that's it. So we have new servers, and what we just did is we simply extracted the Keystone database on new servers, and we kind of formed that ring where we only replicate the Keystone database. Underneath, we have default OpenStack controllers with their APIs, their queues, the load balancers, and their databases. We have compute node as well. As for Ceph, we have the RBD mirroring that is just being in place. So we have two clusters, and what the RBD mirroring is doing is simply replicating from site A to site B and from site B to site A the content of all of the OpenStack pools for Cinder, for Glance, but not Nova, because we are in a disaster recovery event. We are not recovering ephemeral images as part of OpenStack, because by default, when you boot an instance in OpenStack, you have this root disk, can be stored in Ceph or anywhere else, but by default, you shouldn't have any data. Reason is that as part of Glance and your image, then everything has to be templated. So the template of your application should be part of the image catalog. So if you have to recover, the only thing that you need to recover is the data that should, and I should say must be only stored in Cinder block devices. So that's the only things that we are recovering in an event of a failure. We're almost done, and this is something that we have been busy with Sean and Daniel. Don't be shy, Daniel. Daniel, this gentleman over here, basically writing this little book about OpenStack storage for dummies, where you will learn a little bit more about OpenStack and all the challenges and how, well, basically everything related to OpenStack and storage, and how we are solving this this huge problem. So if you kind of the thing is, if you ask questions, you can get a signed copy, but if you don't, you can just get a copy from the Red Hat booth. With all of that, that's all we have, and we would like to thank you for your kind attention.